This is Mr. Martin. These are the video notes for section 4.2. You have the notes for 4.3 as well, but this will just be for 4.2. We're going to be talking about missing diagrams. And we've done a few problems with missing diagrams already. The book likes to introduce things to get you ready for it. But basically, they're going to give you a statement, and from that statement, you have to create your own proof, and then most of the time, you'll have to complete the proof. For the examples in the notes today, I think we're just going to set up the problems but not solve them. Just make sure you follow the directions carefully on homework, quizzes, and tests so you know whether you need to actually complete the proof once you've made your proof. So we've got some important techniques for solving these. Probably the best case for you is going to be if the statement has an if clause. This generally tells you the information that's given. Okay, so if it's in if-then form, if it's in conditional form, it makes the problem a little bit easier. The then clause, our conclusion. So if is the hypothesis, then is the conclusion, generally tells you what needs to be proved. So these are not hard and fast rules. They're just general guidelines. And you're going to have to use a little bit of common sense when you're solving these problems and think about, well, what do I know and what do I need to prove? So number 3 here, if the statement is not in conditional form, what you may want to do is rewrite it. Especially if you're having difficulty determining what's given information and what needs to be proved. So keep that in mind. Again, try and use some common sense and keep questioning, asking yourself, what do I know and what do I want to prove? And I think that'll help make things easier for you. So steps when solving missing diagram problems. Number 1, you're going to use the information to draw and label a picture. And then you're going to use your picture when writing the given and the conclusion for the problem. And then when appropriate, again, follow the directions, solve the proof with a 2-column proof. So let's go ahead and for these we're going to set up the problem, but we're not going to do a proof. We could for some of these we may not know some theorems that we need to yet, but for these we're just going to set it up. So we're going to need a picture, we're going to need given, we're going to need a conclusion. So for number 1, I've got if two altitudes of a triangle are congruent, then the triangle is isosceles. So use the keywords in the problem to help you draw the picture. We need some sort of a triangle that's going to look isosceles. So let's just make it triangle ABC. And we need 2 altitudes. Okay, so I'm going to draw in one over here, I'll call that D, and I'm going to draw in one over here, and I'll call that E. And I think that should be good for our picture. So we're given, so we have 2 altitudes, so I've got CE is an altitude, and I've got BD is an altitude, and I also know that the altitudes are congruent, so I know that CE is congruent to BD, and we want to prove so if the 2 altitudes are congruent, so I have that they're altitudes, I have that they're congruent, we want to prove that the triangle is isosceles, so triangle ABC is isosceles. Okay, and then we could go ahead and we could complete a proof. Again, for the sake of this video, we're not going to do any proofs. Alright, so as always, if you have questions, you're not sure why we did something or why we didn't include something, or any questions you may have, write those down. It'll just take you a second, and then ask me next time you see me in class. Alright, and if you want to pause the video and see if you can come up with your own, feel free to do that as well. So number 2, it says the medians of a triangle are congruent if the triangle is equilateral. So I'm going to rewrite this in conditional form. You notice the if part here is at the back. That still is our hypothesis though. So sometimes in English we'll rearrange things, take out certain words to make it more understandable or make it sound like how we would normally talk, because we don't always talk in conditional form. So I'm going to rewrite this, and it would be if a triangle is equilateral, then the medians are congruent. Okay, so we've got a bunch of keywords here. We've got equilateral, we're going to need that in there. We've got medians, we're going to need that in there somewhere. We've got congruent. All of these keywords, triangle, all of these keywords are going to have to be represented in our proof. So let's start with a triangle. And since we know, if we know a triangle is equilateral, so we'll call it ABC again, then the medians are congruent. So I'm going to need some medians in here, and it doesn't specify how many, so we're going to draw in all three, D, E, and F. Something I want to point out that these three medians, they should go through the same point no matter what kind of triangle. That's something we'll talk about later in the book. Okay, so we've got our picture and given. So again, if we know a triangle is equilateral, so triangle ABC is equilateral. Now, this is where you have to be careful, because we know the triangle is equilateral, and we know that these segments are medians, but we want to prove that they are congruent. So also in here we want to state that CE, BD, and AF are medians. Then we want to prove that the medians are congruent. So we want to prove that CE is congruent to BD, which is congruent to AF. So this would be kind of a long proof. Again, we're not going to go through and do it, but so as a general guideline, the hypothesis tells you what's given, but there is some information in the conclusion part of the statement that is going to be part of your given information. So, again, try and use some common sense and ask questions as needed. All right, moving on to number 3. Again, if you want to pause the video and see what you can come up with. It says the altitude to the base of an isosceles triangle bisects the vertex angles. So I'm going to rewrite this in if-then form. If a segment is an altitude to the base of an isosceles triangle, then it bisects the vertex angle. So we've got a lot of keywords here. I've got altitude, I've got isosceles triangle, I've got base, I've got bisects, I've got vertex angle. So just about all of these things need to be represented in our proof. Again, I've got an isosceles triangle in there somewhere, so whether we know it or we want to prove it, it's usually a good idea to start with a picture that looks sort of isosceles. We'll call it ABC. And we also need an altitude to the base, so it looks like BC is going to be our base, so I'm going to draw in a segment that goes here. We'll call that D. And I think that's all we're going to need for the picture. So given, if we know a segment is an altitude to the base of an isosceles triangle, so we know that AD is an altitude, and we know it's an isosceles triangle, so triangle ABC is isosceles. Now, anytime you're given an isosceles triangle, I don't know if you've noticed it in the problems where it's given, we need to know one part of the triangle so that we know what are the legs, what are the base angles, what's the vertex angle, what's the base. So normally we just specify what the base is because it's easiest. So we'll say with base BC. Now it's very clear that AB and AC have to be the legs. Angle B and C angle B and C are going to be the base angles. So just make sure you specify whatever part you want to. You could specify the vertex angle. I just like to specify the base because it's the quickest. Alright, so I've got altitude, I've got base, I've got isosceles triangle. Now then we can prove, or then you should prove, that it bisects the vertex angle. So prove, and we're going to write ray AD because really what you want to think about here is then the ray associated with that altitude, because remember there's a line that goes through AD. And as part of that line, I have a couple of rays, I have a segment. So we want to prove that ray AD bisects the vertex angle, which is angle BAC. So especially if you have questions about why that's a ray, if it wasn't clear from my explanation, make sure that you ask me. So here's 3 examples of missing diagram problems. You make up your own problem. Again, if you have any questions, make sure you ask me. And then as you go through the problem set in the book, if you're in class, make sure you ask me questions then, or if you're outside of class, make sure you keep track of your questions to ask me when I see you again.